this one very close to the floor, so we can attach in the floor system. Maybe this part is already introduced, yeah, in the previous class, yeah. This type of a duct system, yeah, from the floor to the uh, uh, zone required, yeah. And then other type is a mixed air ventilation. Air supplied to the room at high speed and is mixed in the confined space by local fans to homogenize, yeah, its mass. Okay, this type is we need to other device, yeah, from the outside uh, air distribution. So we have local or what we call fan that attached in the zone or room. Yeah, for example, in the mosque, our mosque, yeah, they implement this type. Yeah, they will assemble the fan, yeah, in the wall, and then in the same time, yeah, at the same time, the hatchback system will be supply air distribution inside of the mosque, and then together we will work together to distribute air, yeah, using the fan. That one with combination, yeah, to homogenize the air distribution by the fan from the outside system in the hatchback, yeah. So actually this one is separate within the hatchback duct. And then other type is piston-based ventilation system. As supply move through the room as a piston. Actually, this one is look like the system of the piston. We have the compressing, and then also uh, other is suck, yeah, suck system in the piston. Same thing when we produce the low of condition of pressure, and then what happen, we will suck the uh, 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 vacuum will be occur, and then we will suck the air supply, yeah, from the outside, and then we go to the room, and then we call that one is the piston based ventilation system, yeah. So look like this, yeah, where we supply, yeah, the air distribution like this, yeah. So will be distribute in the room, look like similar of pressure inside, so will be homogeneous of the pressure condition inside, and then what happen, the pressure will be produced inside here, and then another in the outside of the room will be produced the other of the pressure condition. And what happen with, if we, as we know, the if we have two different pressure, yeah, between one zone to the one zone, there will be process of the flow, yeah. In general, ventilation system is summarized as a bringing fresh air circulating in the it indoor and exciting in the outside. So the same like look like natural condition that introduced previous. So same thing like that. And then we go to local exhaust ventilation system. We have a several type here in the actually the local exhaust ventilation system in implement, yeah. Maybe you can see later on. So for the first, maybe I will introduce the definition first, yeah. So the local exhaust ventilation is a system used to capture airborne contaminants at the point of the generation, preventing inhalation by worker in the vicinity. Actually, we have a special condition in the certain area. For example, in our maybe familiar with the welding system. Yeah, maybe you are already introduced in the welding system lab. Yeah, so what happen? We have a certain condition to circulate what we use in the ventilation for the exhaust. Yeah, in the welding. So once the welding occur, the fan, yeah, will be operate, and then there will be suck, yeah, what produced from the welding, and then will be flow to exhaust. Yeah, so the one is considered under the local exhaust ventilation. Not only that, in application, also in the we can see in the kitchen. Yeah, maybe special when the kitchen is influence under the HVAC system, and then we don't want to distribute the unwanted, like the smoke, yeah, from the kitchen, and then we try to make a local exhaust, yeah, to bring to outside. Yeah, so local exhaust ventilation system can provide a very effective means of the exposure control by minimizing emission, release, and spread of substance hazardous. Yeah, exposure to hazardous substance must be avoided completely in order to control of the substance hazardous to health. Yeah, this one is controlled by the one body. Yeah, then will be pass the standard. The local exhaust ventilation application can be used in the common space such as laboratories, industrial, and kitchen. So like I mentioned before. Yeah? So see, this one is a one that we have already implement, yeah, in the welding lab. Then you can see the from the figure the illustration of the local exhaust ventilation system. We suck unwanted or hazardous from the welding, and then we send to outside. Yeah, for the kitchen also. Yeah. And design consideration, yeah, for the LEV, local exhaust ventilation, is an engineering system designed to reduce employee exposure to some risk of volatile substance such as airborne contaminants, dust, mist, fume, vapor, gas, and so on, that will be effect to our health. It's essentially to consider the design and installations of LEV. The most principle of LEV design are system component process consideration, aerodynamic considerations. That one is part of the parameter need to consider in the construction of the LEV itself. Yeah, so actually it's not only just through out the hazard, but we need to filter first, and then maybe this one also need to do design in the exhaust system for the aerodynamic consideration, because of we try to attach in the building architect. System component, there are 5 basic components in the system. Yeah, so we have air inside here, and then we go to our exhaust here, and then we have hood, yeah, to collect the air, and then we have the duct system to transport the unwanted air, and then we try to clean like filter here. We put here filter here, and then after we consider this one is ready, pass to the quality, air quality, and then we try to send to the outside, by the fan to environment. This one, we have at least 5 component. System component, hood or collector to capture the contaminant close to the point of generation, a ductwork to convey the contaminant away from the source, filter or air cleaning device to capture and remove contaminant from the extracted stream, fan or moving device to provide the necessary air flow. Yeah, this one is how to the component work. And then duct work to discharge clean air to the external atmosphere at a suitable point. This one is the cycle with the 5 component work. Yeah, and then a process consideration. To effectively remove contaminants from the workplace, each element of the LEV system must function properly. This part, yeah, we should be make sure. Then, poor design of any one component will undermine our all performance and the ability of the system to control exposure. And then the last, efficient LEV system are those designed to meet the requirement of a specific job or process and should take into account the following: how the job is done and any specific requirement of the worker, how, where and when the contaminant is being generated, physical state of the contaminant like dust, mist, fume, gas or vapor, yeah, toxicity, relevant workplace exposure limits, yeah. So we need to make sure that under the safe condition. And then we go to other aerodynamic consideration. The general aerodynamic consideration that may be applied to the design, hoods, So maybe we need to design the hood, the better hood, how to cover the kitchen, how to cover the welding part, we need to design, and associated connection should be designed to take advantage of the natural air movement of the machine. So we need to design the duct system that proper, will not disturb to other activities. So make sure this one is not the disturb other activities or other device. Capture hood should be as close as possible to the contaminant source. Sometimes we can see the hood will be flexible, so we can remove close to the object. Ductwork must be as simple as possible and the number of directional change minimized to avoid airflow resistance. And clean air must be discharged to atmosphere at a stable point, avoiding circulation back to the workplace. This one is considered under the part of the aerodynamic system. Now we go the last part from our class, energy recovery. So what is the energy recovery? We should be introduced first as definition. Energy recovery ventilation, or we can call in the short form ERV system, include any technique or method of minimizing the input of the energy. We try to make high efficiency by energy recovery. Energy recovery ventilation is the energy recovery process of the changing of the energy contained in normally exhausted, boiling or space air and using it to treat precondition to incoming outdoor ventilation air in residential and commercial HVAC system. Actually, energy recovery, we try to recover the air distribution after we utilizing as per the air service into the zone or room, and then we try to take back to read by return duct system, and then we try to recovery that airflow by certain condition, like we try to filter, we try to recall again and give to maybe suitable humidity again, and then we send back. So we don't need to serve from the ambient from air. That one is very difficult to recovery. We try to condition the air from the outside. That one is need more energy. Then what happen? We try to recovery what we return air from the return air, and then we can save the energy, because recovery air is more efficient. Consider we try to take totally from the outdoor, from the air from the outdoor. So we can mix within the return air, and then we try to recovery. So that one we can save the energy. So we actually recovery system. They have one part there. Then in that part maybe they have a certain component inside, like the filter and the humidity part. Maybe we can add or reduce. Depend on the condition. In the climate condition, sometimes is higher of the humidity. Then sometimes we maybe in the summer maybe low in humidity, and we can add the humidity. That one is considered under the recovery, energy recovery. Then we can save the much of energy using. Okay, that's all for today. So I hope you can see our task for your attendant. Then please submit in the during a given of duration time for submit the task to consider your attendance. That's all for today. Thank you. Assalamualaikum.